running a $300 million revenue center at a local hospital here in Seattle. We had a patient die because we couldn't get the right people and things to him when he needed it most. This was my spark for why I'm obsessed with solving frontline workflow operations. There are, next. There are 92 million surgeries every year in the United States annually. Next slide. And even if we keep all patients safe, 5 to 10 minutes are wasted on every surgery. Next slide, please. Every minute is costing $100 in waste. This equates to $46 billion in waste annually. Next slide. As a team of clinicians, we have identified that it's what we can't see that's bleeding money. This is especially impactful when more than 60% of margins in hospitals come from surgical services. This impacts every department in the system. Oh, can you go back one? So, what do? Let's make hospitals intelligent. Enabled with sensors and patent-pending orchestration technology, we introduce an essential human-machine feedback loop that engages clinicians, patients, assets, and the building. Next slide, please. We use off-shelf radio frequency technology, and this is the highest accuracy, the most real-time, and with the greatest scalability. Next slide. So this network is deployed over Ethernet. It's common for network infrastructure, and essentially we use stationary tags, stationary anchors, and mobile tags. So this gives us the ability to tell operators what's wrong in the space and provide information to help them make it right. Think Apple Find My, but for clinicians to find what they need and who they need when they need it. And next slide. And think of an intelligent system like GPT, where you can actually communicate with your built environment and say, what's wrong? Where are the bottlenecks? How can we improve? Next slide. So we are B2B, direct to surgical services and hospital executives. Next slide. We anticipate giving hospitals 2x on their investment. Next slide, please. And with a heavy push to market, we believe that we can break even at 16 contracts. Next slide. And that is within 2 years. So we are currently in a pilot at the University of Washington, and we also will be going to market in the coming months. So looking forward to your questions.
Hi. So can you tell me about your intellectual property? I heard you say patent pending. What exactly is patent pending?
Yeah, so we have orchestration technology that we have patented. It is essentially the way that we can orchestrate critical frontline operations. So imagine something like a code call, where the code is at a specific bedside. We have that code called to that location, time, event. We orchestrate the specific team members with the skill sets that are needed to not only get to that location efficiently, but bring the things that they need. And then all of that is also being documented in real time. So that's just one example of how the orchestration technology works. It has different layered impacts where if for some reason specific people can't respond, we still need to get the right people there. So all of that is kind of accounted for in the layers of how our system works.
So is it more so the IP, is it more software, business method based, or is there going to be actual mechanical components like devices, systems?
So we deploy that radio frequency technology, and the thing that makes our software side and where we're going from the agentic AI perspective as well, what makes that relevant is the understanding of the built environment. So we do deploy that infrastructure so that we understand our location, time, events, and then we use that data, we add context, and then we are able to utilize our orchestration technology.
said you're in pilot now.
Yes, we're in the mass spectrometry lab in the University of Washington.
So is your MVP the entire perioperative loop, or is it something like that?
So right now it is analytics. So we don't have the frontline facing yet, but we have the administrative portion.
Thanks.
Thank you.